Hello and welcome to this new video. Today I'm going to record my attempt for the second case of the last 64 of Microsoft Excel World Championship 2024. The second case we played during the game day, which is called Lana Goes Ice Skating. A map-based case seemed easier than it is, honestly. When we saw the case, I thought, okay, this is the kind of case I like, I will smash it. Start to model level 7 during the prep time. Eventually got to level 4, maybe 5, I don't remember. My Excel crashed, so a disaster also in this case. Luckily my score was good enough to move through and go into day 3 in Las Vegas. So let's see how it goes with this second attempt. We have our famous Lana, which this time will need to skate over this lake, in which she will find bananas, ice, and snowmans, which will slow up or speed up the skating of Lana. Yeah, let's see how it goes. So is it a banana, an ice crystal, or a snowman for this cell where this seems quite easy? So let's go with an indirect. Frozen lake, and this is the cell. So okay, forgot to remove the feedback. I forgot also to start the timer. In this level, Lana is only scouting the locations of the bananas, so you can disregard the rule about not being able to change the moving direction. Lana is trying to locate the nearest bananas. How many bananas are within 2 cells if she starts in the location below? So this means will be an offset of indirect frozen lake cell this -2 -2 5 5, if I'm not wrong. Okay, this is a banana, so it will be a countess banana some close. Okay, and here we go. I don't have hints for this. Interesting. Ignore obstacles. Lana starts in this cell, moves in the specified direction until reaching the edge of the lake or an island. How many bananas will she collect? Let's move to my solver worksheet. So first of all, I need to convert those arrows, which were a nice surprise. Okay, so here maybe faster to just move them. Okay, so start my arrow, my X lookup. They're reaching. So it will be start this. Frozen Lake cell. Starts with a banana. So 3. Okay, so count ifs. Banana. Plus count ifs. Banana. Let's go. Not sure the range is big enough. Yes, 700 should be good. Should be good. D6, yeah, should be okay. Okay, so level 4 is I think where I got stuck because my Excel broken. Start by skating 1 square per turn. When she starts on or skates over a ice crystal, starting from the next star, she will gain more speed and move an extra square per turn. Speed increase accumulates. If she starts on ice crystal, her speed on the second turn will be 2 squares per turn. Skating over for the first element, if it contains an ice crystal, will counts as 1 turn. If she leaves the lake or travels on over an island, the turn ends and she stops immediately. Okay, so the tricky part is that yeah, I will show you when we got there. So so speed change, so starts with 1 and this will be this basically. Okay, so let's call this vector, which is this and this, and I will move using the vector. And so basically U18 so it's this. Okay, so let's configure an ice. So if this equals ice is 1, otherwise it's 0. Not sure. It tend to be 1. 22. No. Yes, but to use this. Twenty-two, 23, 24, 25. Okay. So this is basically it, but as you can see, 26, 27. Okay. So ice increase to 3. She takes a single attack to move 28, 29, 30. And in fact, she goes in 30. But in 28 and 29, there are ices, and I'm only looking at the landing position, not the trajectory. So I need something here. I need to break down the space traveled. So the idea that I had during the competition was to leverage the V-stacks. So like when I move of one, there is no issue. The problem is here. So basically what I would like to do is to V-stack this direction 2 times. By doing this, I can apply my pathfinder like this, which allows to build sequential steps. By doing this, I want to run a simple indirect of frozen lake of this. Yeah, of course, doesn't manage the array formula. And then count my ices. So what I did was a big let saying let arrows, V-stacks, arrow and speed. Then path will be my pathfinder of start position, arrows with steps. Then I want the contents to be a scan of path lambda av simple indirect frozen lake path and then I want to sum the countefs of ice contents, and that's it, I would say. Interesting, doesn't work at all. Why? Should be 2 ices here. interesting. Path is right. Oh yeah, of course, this is V. There was I lost the purpose itself. Okay, so at this point I could say something like this. So I get to U30. So I do U35. U54. Okay. Need to see the colors. So okay. So simple, indirect, frozen lake color. Sell this. X match this into this. 13 plus 1, I think. Let's see. So that would have been my solution for the day, but my Excel crashed. So I'm getting some errors. C4. C24. Okay. If this equals this one, 0, there was 1. And if error, come on. 0. Matched 0 here. Plus 1. Update. Still getting an error. Okay, makes sense. Because I might have some might jump over the end of the lake, so okay. So 5, 23, 17 looks fairly good. Let's go into level 5. In addition to level 4, moves through a snowman cell. Her speed will slow down by 1 cell per turn, starting from the next turn. Decreases in speed due to snowman, increase due to moving through ice crystals accumulate. If she reaches a speed of 0, she gets stuck. If she starts on a snowman, she gets stuck immediately. Or gets stuck. Okay. So example 5. This is Isis. This is Noman's. This is quite similar. Plus if this equals no, minus 1 with 0. Minus this. Maximum between 0, otherwise I get negative speed. Change. No. That is max 0. And this. So 19. So or this or speed end equals 0. Might be okay. Let's go for the bonuses first. How many bananas? So count ifs. Banana. How many lake cells have at least one corner touching the outside edge of the lake or touching an island? Didn't do this. I was not sure about the wording. How many cells of the lake have at least one banana, one snowman, and one ice crystal located no more than 2 cells away? Do not include land cells in your calculation. How many cells on the lake have at least one banana, one snowman, and one ice crystal located no more than 2 cells away? Do not include land cells. So what I did is something like this. at least if and greater than 0. Nice. I know how I got this as snowman. This is not length, otherwise it's 0. Okay, this should be it. 2973. Under the level 3 rules, what is the maximum number of bananas Lana can get if she's free to select the starting cell and the direction? So that's the data table. Under level 3 rules, this will probably crash my Excel. According to see level 6 building, Lana starts and following cells and can decide which direction to move. This is the highest number of bananas she can collect. Doesn't look that hard. So transpose my arrows. She gets stuck. Maybe 58. Let's see. And then I think I'm out of time, so the 30 minutes are about to end. Forgot to include example 6, of course. Oh, the question is how many bananas, come on. Third calculation of the data table. Okay, so sum. something really bad happened. Why do I get 15 there? What's this? Yeah, of course I need to take the max, come on. Doesn't look to match the example. AV32. Of course. I had the same problem when skating. Calculate again. What? 98? This equals 0, 0, otherwise is that. I'm probably out of time. Okay, 4 matches. 7, 4, this seems to match. Okay, here we have the bouncing go around the lake, but it's very tough. Yeah, bonus 4 is, I mean, easy. It's just a matter of calculating everything. So I will not do this because, I mean, I'm not up to set up the question. Let's see. Okay. Decent, but not great. Potentially, this would have been, yeah, 800. Oh, wrong. Okay. So, wrong. Yeah, some errors here and there. Yeah, those are worth 88 points. That's interesting. Yeah, this is, I mean, a standard case, but clearly more difficult than the average map case. So good job in to Harry in using let's say common setup and common also subject for this case, but making it hard anyway. So I like this a lot. I will come back for a full solve and also curious to model level 7, which seems like it's really hard. So hope you enjoyed the video. We'll see you in the next one. Bye.